Okay, let's talk about balancing chemical equations using oxidation number method. Okay, so it's very important and very key that for you to do the balancing of equations using the oxidation numbers, you need to know how to determine the oxidation numbers. Okay, so there are some elements that have got the basic oxidation numbers. For example, oxygen, you should know that the oxidation number is -2. For hydrogen, it's positive when it's reacting with nanometals. With metals, it's -1, but it's +1 most of the times. Okay, then the metals go to their groups when they're existing in form of ions. For example, let's say magnesium 2 minus. So that same charge will tell you that that's the oxidation number. In a case where they're existing in solid form without any charge on top, it tells you that it's 0. Okay. So, but we've got the transition elements which are in between the periodic table. They don't have specific oxidation numbers, and they vary depending in which compound you find them. Okay, so let's try to balance this chemical equation using the the oxidation number method. So we'll start with the first part there. Okay, this is what we have. So of course we've talked about oxygen to have a fixed one. So let's try to study carbon and the ion. So I'll go to the other side where the ion is. So when there's no charge shown on top and it's in solid form, it's 0. Okay. So it is only you only get to calculate the oxidation number when it's in a compound. But in a case where it's in form of an ion or in solid form alone, just check the charge. That's the oxidation number. Okay, so we know on the other side it's already a 0. Let's try to determine now the oxidation number of ion in that compound. Okay, so we have got 2 ion atoms there. So say 2x plus, we have got 3 oxygen atoms, and we are saying each oxygen atom is -2. So what is the overall charge of a compound? So there is no charge here, so it's 0. So equate this to 0. Then 2x is going to be equal to 6. Then you find that the value of oxidation number for the ion was what? +3. Okay. So we'll show this. Okay. So it's +3. Okay, so that's the change in the oxidation number. Okay, talk about the other side. Let's talk about the carbon now. Okay. So start with the carbon monoxide. So we know the charge of carbon, let's that be x again. For oxygen, we know it's -2. And the overall charge of carbon monoxide is 0. So this tells us to say that the charge, the oxidation number of carbon in carbon monoxide is going to be 2+. Then for carbon dioxide, in carbon dioxide, let's have some space here. Let's have some space. So for carbon dioxide, it's x, then +2. There is each one is -2, so it's to 0 there. So in this case, our x becomes equal to, our x will be equal to 4. Okay. So there it's 4. Here it's 4. Initially it was 2. Okay. So we've determined the oxidation numbers of carbon before and after, including for ion before and after. But how is this going to help us in balancing the chemical equation? Okay, so ask ourselves the question. So here initially it was 3. There it was 0 for ion, so the change was 3. Now where you have 2, you are going to 4. What's the change as well? So the change in oxidation number is also 2 there. So say that's 2. Here it's 3. So we've got the change in oxidation numbers. Okay. So now, how do you go about it? How do we balance? So we're going to multiply. We're going to multiply. Okay. We're going to multiply by the opposites. Okay. Only where it is applicable. Okay. So we're able to see that we've got 2 iron atoms on the left. On the right, how many do we have? We just have 1. Okay. So in this half reaction, we are saying we have got a change of 3. So the other side is going to be multiplied by 3. So it's going to be 3 carbon monoxide. Okay, we have our ion there, our ion. So our carbon dioxide is also going to be multiplied by 3. So it will be 3 in carbon dioxide like that. Okay. So equally, this other half reaction is also now going to be multiplied by the opposite charge, which is 2. This 2 will multiply this other half reaction. So you are able to see that the ion already has got a 2. So you don't need of you multiplying by the 2 because it will make it 4. So this 2 only applied to this one. Okay. So that's the best way to go about it. It's not always the case that it's supposed to apply to all the atoms, but just try to look at what is going to be the result. Okay. So if you look at this equation, you're able to see that it's balanced. Okay, you've got 3 carbon atoms. For the oxygen atoms, you've got this side you've got 6. Even this side you have 6. 3 plus 3 at 6. Okay, we have another example. Copper reacting with a nitric acid. Okay, so how do you get to balance this equation using the oxidation number method? So when you look at the copper on the left hand side, it has got no charge, so the oxidation number is 0 there. Then let's try to look at the other side where copper is. Okay, so the easiest way to identify the oxidation number without even doing calculations, when you've seen that a transition element, it can be copper, it can be iron, it can be manganese. So look at the reacting power. So the fact that NO3 has got a subscript of 2 means that the copper that was reacting is copper 2. So the oxidation number there becomes 2 plus. Okay. So we've determined the oxidation number of copper on both ends. Then we therefore connect again. We know hydrogen is standard, oxygen is standard, so we'll be interested in nitrogen. And we rate it to the other nitrogen on the other side. So we say that for hydrogen, it's positive 1. Let me write that properly. So you have 1. We'll put plus X for nitrogen. Then we've got 3 oxygen atoms. Each one is negative 2. And the overall charge of the compound there, of the acid, is 0. So you have 1 plus X minus 6 equal to 0. 1 minus 6 is negative 5. Therefore, X becomes positive 5. So we have positive 5 there. We look at the other side, it's nitrogen dioxide. So oxygen again, so say for nitrogen, let that be X. For oxygen, we've got 2. So 2 minus 2 should be able to give us the overall charge, 0. So X minus 4 is going to be equivalent to 0. So our charge becomes plus 4. Okay. So we've determined the oxidation numbers on both ends. So what's the change for the nitrogen, we are moving from positive 5 to positive 4. So what's the change? The change is negative 1. Then for the other half reaction, you are moving from 0 all the way up to 2. What's the change here? What's the change? The change is 2. Okay. So we need to balance these by crossing and multiplying. So we'll start with copper. So copper is going to be multiplied by 1 there. Ignore the sign, of course. So it will still be copper. So we have copper plus. This is going to be multiplied by the opposite 2 there. So it will be 2HNO3 from the other half reaction, giving us, so copper is, this compound is part of the half reaction with the 2, so it's being multiplied by the 1, so it will still be the same. So you've got copper NO3, then you have a 2 plus nitrogen dioxide plus water. So where else is the 2 multiplying? So the 2 is being multiplied by what? By this and that. So where there is nitrogen dioxide, there is supposed to be a 2. So say plus 2. Okay. So before we get to submit our work, we need to look at the atoms are very balanced. So start assessing. So if you look at the copper, you've got 1 copper, it's 1 there as well. Hydrogen, you've got 2 there, there are 2 as well. For oxygen, for nitrogen, you've got 2 here. There you already have 2, but again there's also an extra 2. So we need to make it 4 on the left. So the only way to make it 4 is by is to make this 4. Okay. How about now? Are they balanced? So we've got 4 hydrogen atoms, so we need 4 there as well. So we'll make that 2. Okay. 4 nitrogen atoms. Here there are 2 plus 2, 4. Yeah. So in such a case, you've balanced the chemical equation. And finally, let's look at a bit more advanced question and balancing of chemical equations using the oxidation numbers. So we'll quickly determine the oxidation numbers for all the atoms on both sides. Okay. So let me try to start with the ones that are not important. So of course, in this case, you know, hydrogen has got, it's always positive 1, so it's going to be plus. So here we can say the oxidation number of hydrogen is plus 1. For oxygen is 2 minus. So on the other side, potassium is plus 1, it's a metal in group 1. The oxygen there is 2 again, 2 minus. The hydrogen is plus 1. Okay, so even here the oxygen will be the same, potassium will be the same, what else? Sulfur here it's 0 because it's existing in a atomic form. That's the way it's found on the periodic table. Here oxygen again 2 minus, 2 minus. Yeah, so you are going to notice that the only things that we don't know is sulfur on the right hand side and chromium on both ends. We don't know, so we need to do the calculations to determine that. So we'll start with this side. So we have got a positive for potassium, and there are 2, so it will be 2 multiplied by positive 1 Let's have X for chromium. So we've got 2 chromium atoms, so it will be 2X. Then we've got 7 oxygen atoms, each having -2. And the overall charge of a compound is a 0. So we've got 2 minus 14 plus 2X is equal to 0. So you find that 2 minus 14 is -12. So you have got 2X being equal to plus 12. And you find that the oxidation number of chromium is going to be 6 on the left hand side. So you have 6. Let's try to talk about the other side now. So you've got the chromium there. So 2X for the chromium. Then you've got 3 oxygen atoms. The overall charge of the compound is 0. So 2X minus 6 is equal to 0. Then you find that your value for X is going to be plus 3. 6 goes the other side is positive 6 divided by 2, positive 3. Okay, so it's plus 3. We'll go for the sulfur dioxide there. So sulfur, let sulfur be X. We've got 2 oxygen atoms, so it's 2 multiplied by -2. The overall charge is 0. So you find that the value of X is going to be what? Positive 4. So you have positive 4 for the sulfur. Okay, let's try to now come up with the F reactions where have we noticed a change in terms of oxidation numbers. Okay, so I'll start with chromium. It's moving from 6 all the way up to 3. So what's the change here? It's decreasing by what? It's a decrease by 3. Okay. Then we've also seen a change in sulfur from 0 up to 4. So the change is 4. Okay. So we've come up with the changes, right? We've already seen the changes. So for sulfur, that's an increase. So that's an oxidation. Then for chromium, that is a reduction. So we need to balance up. Okay. How do we do that? We're supposed to multiply. Okay. So this 3 is going to be multiplied by the other half reaction there. So sulfur is going to be multiplied by 3, and sulfur dioxide as well by 3, coming from this other side. Okay. Then we also need to multiply the other half reaction by 4. So, but if you look at K there, it already has a subscript of 2. So you just need to put a 2 to make it 4. The other side as well, chromium has got 2 already, so we just have to put 2 again to make it 4. Okay. So we can say we are done, but it's not balanced yet, because we also need to balance all the other atoms. So if you look at potassium, this is 4 already, so we have to put a 4 there to make it 4 the other side as well. Okay, so let's try to assess now. How many hydrogens do we have on the left? We've got 2. The other side we have 4 hydrogen atoms, so we can put a 2 there. How many oxygen atoms do we have on the left? So 2 by the 7, 14 plus 2 here, 16. Here we have 6 plus 4, that is 10, plus 6 more, that is 16, which is matching up. So therefore our balanced chemical equation is therefore going to be 2 K2 chromium okay, chromium chromium 2 or 7 plus 2H2O plus 3 sulfur. So that's on the reactant side. So the products we have, so due to lack of enough space, I'm writing down 3 sulfur dioxide plus 4 potassium hydroxide plus 2 chromium 2O3. So that's the way to go about it when you're asked to balance chemical equations using oxidation number method, and it becomes very useful where even a question is just generally asking you to balance up. Okay? Because you find that just by you trying to assess and look at the equation, it's going to be very difficult for you to balance it up. So that's it for this video. Just hope that you got the concept of balancing chemical equations using oxidation numbers. If you have questions, if you want us to cover certain topics, comment under the comment section, then we'll be able to guide you. Thank you very much for watching.